We have to change the way we design and build. We have to figure out how we can use technology to build a system or a platform from which we can then scale and build as many of these buildings as possible.
Hey there, welcome back to another episode of The Climate Cycle. Today on the show, we're diving into one of the biggest challenges and opportunities facing Canada today: how to build more housing faster and with a radically lower carbon footprint. To explore this, I'm joined by Oliver David Krieg, or OD, president of Intelligent City, a Vancouver-based company that's rethinking how we design and manufacture urban housing. Canada needs to build close to 6 million new homes by 2030, or 1/3 of our current housing stock, all over again in order to meet demand. We need to build fast, but also in a way that's low carbon and resilient to climate change, so that we're not just rebuilding or retrofitting all of these homes in a couple of years. Intelligent City is taking this challenge head on, combining dynamic, algorithmic design, industrialized construction, and mass timber to create better, more sustainable homes faster. In our conversation, you'll learn about the important role that buildings play in climate change and how mass timber and prefab construction can shrink both the upfront and operational carbon emissions. You'll also hear about what's slowing down construction today, and we'll unpack everything from the financing models and incentives at play to permitting and building codes. Odie also shares his perspective on what needs to change across the construction industry and supply chains to really accelerate mass timber adoption. And now, without further ado, my conversation with Odie Krieg. Oliver, thanks for joining us.
It's great to be here. Thank you.
Awesome. So I would love to maybe start off with a little bit about your journey and how you kind of found yourself working at Intelligent City. From what I saw, you were kind of employee number one. I would love to hear, like, what was that journey to working there and where you are now today?
Yeah, from very early on, I was part of Intelligent City. Although that being said, the company has had various iterations over the years before I joined. My background is in architecture. I studied architecture in the early 2000s into the early 2010s and thought that I would simply become an architect. I think at that point in time, a lot of architecture schools were really focused on teaching good design and preparing architecture students to, design good buildings and potentially, I think a lot of sort of motivation for architecture students at that point, and maybe still today, is to become a star architect, right? To become a really good designer that is known for really beautiful buildings. But how they actually get made and how you materialize the designs was never really such a big focus. Lucky for me, that changed as I was studying in Germany. And around the time I was halfway through my studies, we had a new professor and a new institute founded for, they call it computational design and construction. So computational design means parametric design, or you program the design. Or as you maybe want to say, instead of designing the building, you design the algorithm that makes the building. And by doing so, you can then go through hundreds of thousands of iterations and test different assumptions, right? So it's a bit of a more scientific approach to design. And I guess I was nerdy enough to really like that idea and got really into it. And then we also happened to get an industrial robot, like one of those big robot arms that make cars usually, or that sit in factories. And we put a milling spindle on it and we milled wood. We milled various things. A robot is extremely versatile. And so we engaged with that machine, which is, it's as big as a human, it can lift 200, 300 kilos. It's extremely massive, extremely forceful, extremely fast. It's kind of scary, but also it really engages you to think about how you can make something. It's not necessarily the robot itself that is so interesting, but I think it's the fact that it's such an interesting device and it's easy to program that really got me and others into this idea of, well, let's look at how we can make things, and that may inform how we design things. And so the next few years, I would basically come up with different ways to cut wood or mill wood into different shapes, build a logic on that, and then build some kind of algorithm that would produce a design that can be made with that logic. And I ended up doing a PhD in that field. So I stuck around, did a lot of research projects, and we started to really build a big research group, basically in timber construction or timber design. We built larger manufacturing processes, not just one robot, but multiple robots working together. not only milling, but also putting things together, gluing things together, screwing, nailing, you name it. But at some point in 2017, I ended up teaching a workshop on robotics at UBC in Vancouver. And that's how I met the co-founders of Intelligent City. And they were at that point already basically, I would say, in the second or third iteration of that idea. They were architects. They had been working in the city for a decade or two, and they were designing buildings specifically. I'm switching completely here now from tech to architecture and community building, but they were looking at how to build better housing, really. I think their influence, also having worked and studied in Europe and lived in Europe, their influence was really sort of that mid-rise idea, and in Vancouver and all of North America at that point, you had really sort of the downtown high-rise buildings, and then you had all single-family housing, right? And there was nothing really in between. And they really liked the idea of building 4, 6-story buildings, maybe courtyard buildings. So you have sort of an inner courtyard where you go up to your apartment and you build more of a community. And they tried that in various ways. And by that time, in 2017, they had figured out that, well, if we know how to design these, it's hard to build them. And if we get to build them, it's really just a one-off. So we have to change the way we design and build these. We have to figure out how we can use technology to build a system, basically, or a platform from which we can then scale and build as many of these buildings as possible. Combine standardization with a level of customization, basically, through the technology. And that's when we met. And I, with my background in robotics and parametric design, I felt like, actually, personally, the first time that I could apply that knowledge in the real world, not just to build pavilions and little experiments, but to actually engage in the real world with construction and figure out if there's a way we can combine these things to build this kind of platform, to build a variety of housing solutions.
Wow. That's a real right place, right time, the universe bringing the right people together story.
Super lucky.
Yeah. Yeah. That's really interesting. The parametric design is really fascinating. And I think that was one thing that really stood out to me when I was doing research on the company, this idea of, almost like a programmatic approach to, what are the constraints, and kind of almost like it seems to kind of evolve within those constraints is a really interesting approach. And it seems to really fit that idea of how do we make this scalable, repeatable, over and over again type of mentality to like create a platform out of this.
Yeah, totally. It's funny because design is such a subjective matter. And I think people who are educated in design oftentimes don't necessarily think about a sort of a more systematized approach to it. And then you have engineers and other people who think a lot more about a systematic approach to things, but they're not educated in design. At this point, it's a very simple change in how you design. It's a very simple logic. And the logic is find the rules that make your design. Just can you write the rules down that make your design happen, right? Where do you start? The boundary of the building. What do you do then? You divide it up into a grid. How, right? Or you start on the bottom left and then you make a 12-foot increment and you draw a line. That's where the grid is, and so on and so on. Where do you put the elevators? Where do you put the staircases, right? Write the instructions down. And when you have that, when you have the rule set, and obviously it's a very long list because you have to get into the bits and pieces, right, that make a building down to the screw and the cladding and so on. Once you have written all of that down, give all of these rules sort of, for example, a minimum value and a maximum value, right? So your grid lines are not always 12 feet apart. No, they can be 10 feet, they can be 13, 14 feet. And and ultimately you build your design system.
Right.
It's almost like designing a board game. Design the game itself, and you design the rule set, you design the board, right? And that's how that's the recipe to build a parametric design system for anything. If you apply it to multifamily housing, however, the list gets really, really long and the dependencies get really, really complicated. And we actually realized along the way that there are other things that are a little bit more important than figuring all of the design from start to finish out. And so we ended up ultimately focusing on the back end of all of that, where basically once you have a design, how do you ensure that this is a buildable design? How do you ensure that you actually see every part that's in our components that we make, and then you translate that into manufacturing instructions in the factory, because
Right.
that became the more important aspect, because ultimately the factory only works if you give it instructions, and you have to make some instructions. So you'd rather figure that out before you figure out some kind of automatic parametric way of designing the entire building. That idea of parametrics is still fundamental to what we do. Just through the years, we've learned that in order to enable that level of customization, that not everything has to be flexible. In fact, very few parts have to be very flexible, and for the most part, the rest can be very standard. You have the same types of columns, the same types of column connectors, the same types of cladding clips. So there is a level of rigor and standardization, and then there are some really specific things that can be very flexible, and that allows you to basically accommodate all sorts of design ideas that you can have.
Interesting. Okay. Maybe we could orient a little bit on what the platform looks like today. There's an element of the parametric design, but there's also the manufacturing side and actually building this thing. Could you talk to me about like what is Intelligent City today? What does it do? And what does that really look like?
Yeah, it's a really good question, because we had a lot of not different ideas, but a lot of ambitions in the beginning of having a really holistic approach to how we design and deliver buildings. And over time, like I said, we kind of started to focus more on some things that mattered immediately. So originally, we did think that we would really design and deliver buildings more holistically, and we would be, fully in control of how every apartment is designed, and we would have certain options for those apartments and what goes into those apartments. But ultimately, we decided already very early on that we would focus on the structural system of a building, the floors and the columns, and the envelope of a system. And the reason for that was we wanted to make our buildings out of mass timber, using mass timber. You were able to use mass timber in Canada, I think around 2014 is when it became part of the building code, decades after Europe already started using it. So pretty quickly, architects and engineers started to use it because they were already relatively familiar with it. And so when we started in 2018 to develop our building systems, our components, we thought, well, mass timber is a really good idea. It's an up-and-coming material. It is very sustainable, potentially carbon negative, depending on the end of life scenario. And it's a machinable material. It's easy to process in a factory. It's lightweight. You can transport it over long distances compared to steel and concrete. It is a tenth of the weight. The strength to weight ratio is much higher as well. So it has lots of potential. And so we wanted to use that as our base material for our buildings. The problem with that was that there, aside from companies that made mass timber slabs and beams, so cross-laminate timber, CLT, and glulam beams, or LVL, which is basically thick plywood. All of these companies, they made the materials, but they didn't make more with that, which is the same in Europe as well. You have these mass timber suppliers, they make a ton of materials, but they don't actually make them into building components. That's the job of a different company. And there wasn't any company in Canada, or I think in North America for that matter, that used mass timber to then assemble that into finished building components. So if you take the envelope panel, for example, envelope panel for us means it's everything. It's from the structure to the cladding, including the windows. We manufacture all of that. So it's a fully finished envelope. It's made into panels the size of trucks or smaller, and then they get assembled on site. So we focused on those. We wanted to make floor cassettes, or floor, sort of double layered floor panels. They have a cavity space, so we can include services. So they are flat
Right.
packed, 2D modular construction. Basically, they are flat pack components that have as much integration as possible, essentially. And the envelope panels that are also flat packed, and they include the insulation and the cladding and everything. So they are also integrated in that sense. And so we decided we should make or develop manufacturing technologies to make those, and obviously with as much automation as we can, so we can really showcase that we can produce a lot of those panels, at scale, with enough of design variability to build a lot of different housing projects. And so that's how we went from developing just a design logic to developing manufacturing, right?
Yeah.
And since then, we really focus on those panels. And you could, if you strip it all away, you could say Intelligent City makes floor panels and envelope panels, and that's it.
Right.
And
Right.
in fact, we do, and we do supply them to different projects, right? We don't have to be the architect. We don't have to be in control of the entire process. If there's a building that has certain criteria in terms of design and so on, we can apply our components to that building and we can supply that. So that's ultimately where we ended up focusing on. And then operating a factory, of course, is costly. It takes a lot of energy. And so we really focused on, if we supply a certain number of components and make them in our factories, we can be a good business. The business model can be proven out, and ultimately over time we can maybe make more of the building in our factories, or we can be more in control of the design process, because we still know that at the end of the day you have to have a very integrated team. You have to really look at the design of the buildings and at least provide the rules with which you can design a building, so that the architect who designs the building will design in the way that we can build it. So that's really important, that integration, right? So that's how we ended up in the last 3 years, and that's how we started to deliver our first projects.
Gotcha. That's really great to hear that process, actually. I mean, it makes a lot of sense now hearing it. I'm sure it was a process to get there, but it makes a lot of sense to kind of start with that as like, this is a foundational business that works on its own, and over time layer on those pieces that you have in the vision for parametric design and like bringing it all together. So it's really cool to hear that kind of approach. I would love to maybe talk more about mass timber and understanding specifically like the intersection between building housing and climate change. Because I think we can talk maybe a little bit about just that footprint, but the idea of, Canada and many other countries facing a housing supply shortage, we need to build all these homes. You can kind of see this like carbon bomb kind of, all this carbon about to be emitted from building all of these homes. So I'm curious to hear your perspective on like, what is the kind of carbon footprint climate impact of building more housing, and what is that intersection with mass timber?
Yeah, housing construction in general is a huge emitter of greenhouse gases. In fact, the statistics say that the construction operation of buildings, or both together, is responsible for about 40%. And that's because you include the transport, you include the resource extraction, right? And then in operations, you include the energy needed to operate buildings. So it's a big overlap. Other industries, depending on which statistics you look at. And so ultimately, to construct buildings, to operate buildings, we are at about 40% of greenhouse gas emissions worldwide as our industry. So we definitely have a huge impact on making our world more sustainable, and a huge opportunity. And in some ways, haven't really looked at it in that perspective, right? A lot of clean tech is focusing on transport or on energy, but it's not really looking at just how we build and operate buildings. So if you can use renewable materials to build buildings, and if you can use renewable resources to operate, or renewable energy to operate buildings, then you basically reduce that from both directions. And so one really important aspect is, of course, to make building more energy efficient. That's just a really fundamental aspect to any construction method. You just add more insulation, you make the building more airtight, which is a good thing. It's important. It doesn't mean you run out of air inside your building. You also don't run out of air in your car, right? You have ventilation, so that goes hand in hand. But in fact, the truth is, if you make your building more insulated and more airtight, you need actually less ventilation than what we have today, because right now the major factor influencing the size of HVAC systems and ventilation is actually that we are losing too much energy in our buildings. And so if you insulate buildings more and make them more airtight, that reduces the HVAC system size, the ducting size, and that reduces in turn maintenance and the electricity needed to operate that equipment. So you kind of just have these cascading effects of just buildings become less and less intense, basically, to operate and maintain. And the other part is what you call the embodied greenhouse gas emissions. So the energy and the greenhouse gases that get emitted by making the building, making the materials and putting the materials together in the building. And mass timber is it's a material like timber in general that comes from trees, and trees use up CO2 when they grow. In fact, they use up more CO2 than what's in them at the end, because they emit the oxygen again, right? So the statistics, I think, is about 900 kilograms of CO2 get used up in the growth of a cubic meter of wood. And then that cubic meter of wood only weighs 450 kilos. The other 400 kilos are the oxygen that gets released back into the atmosphere. So wood is carbon. And as long as you don't burn it, at the end of its life cycle. You can keep it, you can reuse it, you can recycle it, you can put it in the ground. And even if you burn it to make energy or electricity, which in some ways can still be better than burning coal or oil. And so there's a net positive effect there too. Even if you didn't include all of that, simply the extraction of the resources to make concrete or steel is much more energy intense and emits more greenhouse gases than the extraction of wood.
Right.
So the idea is using mass timber is that if we manage our forests sustainably, which also means that we should not log old growth forests, we have to manage, dedicate certain areas in our forests that we can regrow and reuse. So we have a sustainable forestry. If we do that, we have more than enough forests and growth available in Canada to build all our housing out of mass timber. And that allows us, in combination with higher energy efficiency, to ultimately build our cities carbon neutral. And so that's what really excites us, but excites me. We have the materials, we have the technologies, we just have to adopt them more broadly and make sure that the entire supply chain is sustainably managed.
Okay, that's really interesting. So, in terms of mass timber specifically, compared to other materials, the actual raw material extraction is lighter in terms of carbon footprint and all of that compared to, concrete or steel, easier to transport. And then trees naturally are sucking up carbon and releasing oxygen into the atmosphere, that kind of natural sequestration. You mentioned end of life, and it seems like the question of, is it better for the climate is like, it depends. And it seems like end of life is really important. Can you kind of speak to that aspect of it?
Yeah, no, that's a really good point. And I think it's good to talk about it because we shouldn't be too biased and just try to ignore it. But the truth is that even if you do include it in your life cycle analysis, the material is still a lot better than any other building material, right? So even if you do end up burning it, you burn it in specific power plants that are made for that, and they capture the CO2, and you don't release everything back into the atmosphere, and you produce electricity at the same time. But it is a good point, because if you don't include the end of life cycle, then wood is carbon negative, right? It sucks up more CO2 than you emit in the harvesting and the processing of it. Basically, up until it's become mass timber, CLT, there are certain processes that emit energy or electricity and greenhouse gases. The end of life, there are basically three scenarios that are usually in the academic literature that are usually referenced. One is that you burn it and you produce electricity by doing so, or you reuse it, so it goes back into another life cycle stream. So you could take, for example, the CLT that we use, and you could cut it up and reuse it as OSB or some other timber materials, MDF fiberboards, right? So you can make it
Right.
into kitchen cabinets and things like that. So it's not lost, at least not for another few decades. And the third part is that you put it into landfills and you bury it, so that the CO2 doesn't get emitted, or at least not emitted right away. Now, there are things that we truly don't know exactly, and we have to put more research in. One is that, yes, if it is in the ground, will it stay in the ground, right, over 50 or 100 years? And the other aspect is, if you have a forest that you regularly harvest, every 20 years or so, you go through and you harvest the trees. Or I think ideally you do this in phases, so you don't always just clear cut the forest, because I think there's some research already at this point that says that if you do clear cut a forest, the after effect of that means that the soil emits more CO2 or more
Yeah,
methane, I think, afterwards. And so we have to be careful how we harvest trees. And I don't think that the judgment is truly out there yet either. So we have to be very careful with that as well. And that's why sustainable forestry, like they do that in Europe and in Germany and Switzerland and so on, is very important to keep that balance.
that's fascinating. Thanks for unpacking that. The other kind of related issue is the housing crisis and this huge lack of supply. I'd love to get your perspective on that, and specifically what's broken and how we build today. Maybe like, what are some of those big challenges from the supply perspective?
Yeah, a lot is broken. It's a very difficult topic, and I have to say I'm not an expert in housing, and I know that I'm reading a lot about it. I know there's a lot of ideas out there on how to fix it. I
Right.
believe it is a very complex problem, and it requires a very complex solution, which means a lot of different things need to happen for it to change, right? Basically, our company is trying to build more housing. We're trying to engage more developers. We're trying to help developers make housing go faster. It's a lot of things that we see, I would say, related to just a few topics. One is, first of all, if we want to build a lot more with prefab and with mass timber, or even with other materials, right? Prefab, you can prefabricate building components out of steel, out of stick frame, out of mass timber, even concrete to some extent. To allow for that to happen more, we have to invest. It's quite simple. We have to build up an industry that hasn't really existed. It has existed in Europe, especially in Scandinavia. A large percentage of houses and multifamily buildings get manufactured, and they look fantastic, IKEA style. They get put together quickly, high quality, very efficient, cost efficient, and so on. We just don't have a lot of companies in Canada that can do that. Intelligent City is one of a few that are trying to really industrialize construction. So it needs investment. Then you need the right permitting process, and you need the right building codes, and you need the right financing vehicles. So to unpack that real quick, financing is an issue because a lot of developers are used to spending very, very little money for the planning process, and then getting the project tendered, and then they get a price, and then they get construction financing, and then they execute. If you use prefab, you have to engage a prefab company and a builder that can build that much sooner, and you commit also a lot sooner, and then you need more financing sooner. So you sort of front end the financing, and in return, you have faster construction time. So the financing looks different, and some banks are uncomfortable with that, and only recently, for example, CMHC has only recently truly understood and accepted what prefab means for the financing of a building, and so it's changing, but it takes more to change that, to make that more the standard, right? So here are the incentives to use prefab. The prefab company gets the right financing so they can start constructing or manufacturing the building even before construction happens, right? And then building codes are a really tricky thing as well, because they're very different from jurisdiction to jurisdiction. And as long as we have differences, it's difficult to find a standardized platform that works in every jurisdiction, right? You need scale. These companies, these manufacturing companies need scale. They need to output thousands of homes a year, and they need the certainty that they can put a building in Manitoba and in Ontario, and there shouldn't be a big difference in how those buildings look like, right? That's
Yeah.
what other industries have established, the car industry and the electronics industry. These are all nationwide or even continent or even worldwide standards that allow a company to sell their product across borders. And for us, in the construction industry, it's different. It's different in Vancouver than it is in Surrey and in Burnaby and in Richmond. And the GTA is relatively evened out. That's pretty good. But then, you go to Ottawa or you go to Montreal, and it's different again. So we need a similar regulation in those jurisdictions to allow for that. So these are sort of the more administrative financing problems that we have. Yeah.
Yeah. That's so fascinating. It's interesting to hear those different layers. And it is such a complex problem with policy changes, our, immigration strategy, or whatever it may be. Like, all of these things influence it. You mentioned the financing and kind of that mindset changing. Could you explain a little bit about how that mindset is landing with developers? And, is Intelligent City, like when you're building, is all of that in-house and you have control over that? Are banks receptive now to the risk of a timeline is shorter? Like, maybe just unpack a little bit or some color to that financing side.
Yeah, definitely. It has definitely improved.
Okay.
I will say that. I think it was sheer impossible probably 5 or 10 years ago. It depends on both the developer and the financing institution. So I think developers, as well as builders and all the trades, ultimately the entire industry needs to be educated on what prefab really means. What happens on site when you have larger building components that are manufactured and they get put together on site. How do these processes change? They have to be open for that, and they have to really buy in. And that's our experience once we engage with a builder, for example, because we don't do the on-site, right? So we deliver our components on site, and the builder puts it together, especially the rest of the building, right? There are foundations, parking, mechanical, electrical, plumbing systems. These are all, at this point, they're not manufactured, they're not prefabricated, so they are all still traditional. So for a builder, they need to come to the understanding that there's a certain portion of the building that is manufactured, it comes on site, is installed much more quickly. And then there are other things that are as they used to be. And sort of understanding those changes just requires collaboration and a lot of explanation. But once you do that, usually it's pretty clear that there's a lot of advantage when you use that method.
Yeah.
And so that's just an onboarding process, I would say. And it's funny, but it just takes a while to do that. And almost every builder needs to go through that discovery process and understanding by themselves. It's really hard to just force it to happen, right? So that's one aspect. And then for the developer, it's quite similar. The developer also needs to come around to understand what that means for their design process. I think the biggest hurdle is that building buildings is a very risky process. And the less certainty developers have on cost and yield and rental income, or sales income if it's a condo building, the less certainty they have, the less they are willing to invest up front, because usually it takes 2, 3, 4 years to build a building. So what do they know 4 years ahead of time what they can sell the building for when it's done, right? It's sheer impossible. So I totally understand why developers are careful with innovation, because it could mean that if just one of their buildings doesn't make money, they could be out of business. It's not like it's an easy thing to build a building, right? And they are looking at 10, 15% profit margins. And if they look at that, and that shrinks over a course of 4 or 5 years, well, they could just invest in a GIC and they would get more money. So why would they build buildings?
Right.
So they need to know that this is a viable process. They need to know it's proven, it's supported by the government, and in fact, it accelerates the delivery time. So if everything works and comes together really well, you have a faster planning time and you have a faster on-site construction time. And so that actually means your risk shrinks, because now you can make a building in a short amount of time. Fewer things can happen, right? And the cost is more certain too, because the manufacturers of these building components have a much more even cost structure that doesn't change too quickly, just like car manufacturers. And so less fluctuation, a faster delivery, that can help ultimately to make a building, a building project a more reliable business model. But if it doesn't work, it could be catastrophic. And so the developers just need to see that it works. And I think there's really no way around just doing it one building at a time and proving it out over time, right? And for a single company like Intelligent City, this may take many years, but if more companies do it and more developers learn about prefab and industrialized construction over the years, this will take off. And that's sort of what we're seeing. And there's a lot of developers we talk to that are really, really interested, dozens more than were interested just a few years ago. You can really see that developers understand. So I think we are doing the right thing. Could we do more as a country? Yes, for sure. But I think you can see the effects already. Developers are A, they're interested, they've seen examples. B, they're being incentivized at least a little bit. And C, there is proof in the market that really shows these buildings can go faster, they can be more cost effective. So it's slowly being adopted, I would say.
Yeah.
And finally, for the financing, you need a little bit more money up front and less in the end. But in return, if you have shorter project timelines for a developer, what that means is they can deploy the capital more quickly and they have a faster turnaround. And so that means they can ultimately, that's what we're talking about here, I think we can build more housing, right?
Right. Yeah, you get the return that goes into the next project and you keep moving.
Exactly.
Yeah, it seems like, getting more projects done and more people seeing them get done, even the tacit knowledge kind of moving in the industry is all really important. If you have no one in your firm who's ever seen this before, that is a much more daunting project to take on versus, oh, we have a couple people now who've done it, who understand it. So I understand, I can totally see how it would, take time to kind of like build that momentum. It seems like over the past maybe 5 years, prefab, mass timber really seem like they've taken off in terms of excitement level, the potential being more recognized. What have you seen kind of driving that excitement about this type of building?
I think a few things. One is certainly that the world is just coming around to understanding we need to build more sustainably, right? Just generally, I think people are more accepting of the fact that if we can build with more sustainable materials, we should, not like whether or not climate change is real, whether or not it's our fault. It seems that it's better to use more sustainable building materials anyway, right? We're running out of sand for concrete. Like there are so many problems that we have if we were using more concrete and more steel, or at least much more than we are using right now. And if we want to build twice as much housing as we're doing right now, just the amount of concrete that would need to make the amount of sand we need to extract is just, it might not even be possible. So let's look at other materials. And I think mass timber in particular is just an attractive building material. It's not just sustainable, it's also beautiful, and it's biogenic. And so there are studies that the material, if it's exposed on the interior in your apartment, if you see it, it balances moisture content and the atmosphere basically in general. So
Oh,
it
interesting.
makes for a nicer environment in the
Right.
interior of your apartment. And on top of that, it looks nice. If you have, a wooden ceiling or a wooden wall, some people make that as an accent wall, right? In a mass timber building, you just get that for free. And in fact, you need to drywall less. So you actually have less drywall, less paint in your apartment, which are also not the greatest materials to breathe, especially from a new build, right? You have a lot of
Yeah.
outgassing and things like that with mass timber. That's not the case. So it's just a nice material to build with. And I think a lot of people, that's at least our experience. Once people have been in a mass timber building and they have experienced it, that's when it really clicks and they realize, wow, this is a beautiful building. It's, beautiful apartment. It feels comfortable, natural, warm. It feels more human, right? It feels just more like living in nature. And I think people like that. Whether or not it's sustainable, that's just a cherry on top. Right now, you get a sustainable building on top of that. And there are certainly some developers that have certain ESG requirements implemented over the years, and that's
Right.
driving them to look for new methods. But there's innovation in concrete. You can, there is innovation that makes concrete less carbon intense. There's innovation in steel as well. So that's not the only thing. It's really sort of that combination of having a much more livable material
Yeah.
that makes it so attractive.
I wanted to kind of pull on a thread you mentioned there. For developers, what's the incentive to actually adopt? If you've been doing something the same way, you could keep doing it. You mentioned some have ESG requirements, and I've seen that more on the commercial side. For sure, like the investment side, they're starting to ask those questions. What's really the driver for developers to adopt something like this?
Yeah, it's a very good question. And I think it's sort of the same question for any industry when you have the possibility to change the way you do things dramatically, like with electric vehicles, for example, right? Or solid state hard drives, right? Things like that, 5G instead of LTE and things like that, massive investments, big changes. Why are we doing it? Probably because it's better, right? We can make things better. We can make them, whatever industry you pick one, cheaper, faster, more safe, easier to process, easier to manufacture, easier to recycle. So I think for mass timber, for developers, there is certainly an incentive sometimes coming from ESG requirements. Some developers are financed by institutions that have ESG requirements, and then they say, well, if we deploy our capital, we want that capital to be carbon neutral. You better figure out a way to do that. And so the first incentive there is to use mass timber. The city of Vancouver incentivizes the use of mass timber by giving additional density if you use it, because they say, well, maybe you might need a slightly thicker floor slab, so you can't squeeze in 10 stories into the height restriction, or 8 stories, whatever that restriction may be. So we'll give you another floor as an incentive to use mass timber. So there are certain ways to incentivize the use of more energy efficient buildings or energy efficient building materials. And so that's an incentive. We've also heard that, just as we just talked about it, the fact that the material is in a way more beautiful and people like it more, that the building also has more value when they use it. That is something, I would say that is still difficult to put a number behind.
Right.
It is relative, right? So we don't want to have a side effect that our buildings are suddenly luxury buildings,
Yes. Yeah.
because ultimately, the more we build, the more everyone builds, the lower the price for housing. But relatively speaking, mass timber buildings are more attractive than buildings made of concrete or steel. They also have the potential to be longer lasting. If you build your envelope right, which is simply what we are doing as a consequence of building more energy efficient buildings, buildings last longer too. So they have a longer value, and that plays a big role as well. So that combination sort of incentivizes developers to explore mass timber. And yeah, we have seen more and more be serious about it. I think for every developer, this is a multi-year process from being interested, getting educated, touring mass timber buildings, and at some point they will pull the trigger and say, let's try one. We don't expect a lot of returns, maybe because it's the first time everyone's doing it. We might need more planning time to all get comfortable. The builder might not have used mass timber before. So let's try it. But if it's successful, we know if we do it right, it can actually be better financially for us.
Yeah, that's really interesting. The parallel to solid state drives is really interesting in that we want to pursue better. That makes a lot of sense. And I think as someone looking to buy a house, you're looking for what is the best I can get for my money. So I'd love to talk maybe about where the company is now. What does growth look like today in terms of projects completed, the pipeline, and kind of, what's coming up in the next, year or two?
Absolutely. It's it's been a long time for Intelligent City to actually get into commercialization and to start building buildings. Just for those reasons, to convince developers to use mass timber, to convince them to use prefab. These are a lot of big steps that developers and builders have to take. And we appreciate that, right? Especially if you are a new company, you're a startup, and you do this for the first time. Who in their right mind would trust us, right? So we had to prove a lot of things up front. We had to build mock-ups, we had to get certifications, and we had to do a lot of testing to prove out that our components are structurally viable, fire safe. The envelope is airtight and watertight, resilient on seismic events, and all of these things. These are all standardized tests that anyone can go through, and ultimately they give you a certain certification that your building components can have. Especially in this case, in case anyone's interested, it's the CSA A277, which certifies prefabricated building components in Canada. Basically, we can say whatever's inside these building components is according to the building codes, and it will perform. It's our guarantee. So a long time was spent really just doing that while we were pursuing projects. And then early last year in 2024, we started production on our first building. We only delivered the envelope, but it was a pretty important envelope for a 9-story building in East Vancouver for the BC Indigenous Housing Society. They were building an affordable housing project for themselves, for their people. And so that's become a bit of a landmark building. The cladding has basically what they call a basket weave pattern. So you have strips of cladding with different colors that interweave. It's really fascinating. It was a bit of a puzzle. So it was definitely very custom for us to build, but we said, this is a good opportunity. We should absolutely try to make that happen. And just sort of for context, it was 122 envelope panels. They were all as big as a truck. So you can imagine it's a massive undertaking. And those were installed throughout the summer. And the building will be done sometime in the summer of 2025. They are working on them. So that was a really exciting project, and it really sort of tested our ability to execute and, set up the factory for true operations. In fact, our factory is operating on 2 shifts. We basically work through the weekend. So we have 2 different teams to enable the output capacity that we need. And now we are manufacturing our second project, which is in Toronto. It's a 9-story project, also a rental project with a private developer, Windmill Developments and Leaderland Developments. And this time it's the whole thing. It's the structure and the envelope. So basically the on-site construction is, up to the ground floor slab is concrete. They have a concrete core. It's a high-rise building. It needs a concrete core. Now they're waiting for our components. So all that is done. Our components start shipping in a few weeks, and then starting, in sometime in May, early May, we will start the install of our components. And the exciting thing is if you put these floor panels and columns in, and then the envelope behind it, all of this goes really fast.
Yeah.
So we are expecting the install time of the structure and the envelope to be only about 80 or 90 days. So we'll see. Even if it's a bit longer, I think it'll still be an outstanding result. And
Yes.
we're extremely excited about that. And beyond that, we have many other projects in the pipeline. A few are confirmed, many are not. That's just the nature of the construction industry, right? But we're seeing a lot of interest in Toronto or in Ontario in general. And so we know that we will have to expand into that market properly with an individual factory. And that's really been the goal of Intelligent City, is that we develop a platform from which we can design and deliver a variety of multifamily projects. And we can set up a factory in Vancouver and in Edmonton and in Calgary and Toronto and Ottawa and anywhere in Canada, really, in any city that has 500,000 inhabitants or more, you can easily set up a few of those factories. So it's not just Intelligent City. I would say we need a dozen or so manufacturers that make building components or modules for residential construction, and they could all set up shop in different cities to deliver ultimately across the world. That's sort of the idea. Can we set up a factory in every major city in North America? Yeah, probably. That's the goal.
Wow, that's really exciting and a very interesting market where the demand is, I mean, as high as it's ever been, and there's space for that many companies and people in the ecosystem to deliver these types of projects.
Yeah, it's almost inconceivable, right? We're building
Yeah.
250,000 homes a year. We should be building twice as much. That's what CMHC already said a few years ago. About a third of that is multifamily. So, we're building, I believe, 20,000 units in Vancouver and 40,000 units in Toronto every year. If we set up one factory in Toronto, we would maybe do 1,000 homes a year. So that would be 2% of the market share, right? It's nothing. There could be so many factories. We just have to come together as an industry and adopt this at scale, and we could make it a lot simpler to build housing.
For sure. Yeah. And I think too, clearing some of those building code hurdles or kind of simplifying that would probably be a big unlock as well.
Totally.
So I want to just end with a quick rapid fire for you. So really fast, don't need to put too much thought into it. Number one, what is a book or other, like maybe it's a magazine that you'd recommend people check out?
I did not think about that. I'm just looking at my shelf because there is a book series called Prefabricated Housing that I find really good. It's a really good explanation of just all the constraints and sort of the design aspects of it and like logistics on site. It just explains a lot more about what it takes to change our industry.
Cool. That's a great recommendation. I'll put that in the notes. And then what is a piece of advice you would give to someone looking to start working in climate or sustainability?
I think the advice I would give is think about what technologies could impact or could have the biggest impact in the future. I think it's important to think ahead of what consequences certain technologies could have. For example, mass timber has a lot of potential, but we have to think about the entire supply chain. We have to think about forestry. We have to think about sawmills, mass timber plants, about timber companies, and then about building codes, permitting, financing, right? So just a single technology can have a huge impact on many different fields. And if you think through it that way, battery technology for cars is a similar approach, right? Or heat pumps for buildings. Think about what those consequences are across the supply chain and the life cycle of those technologies, and where you can have a really good impact yourself, and like where can you slot in, and maybe you can slot in somewhere where you have sort of a cross-sectional functionality, right? Maybe if you know about financing, now you can help all of these technologies to progress faster.
Yeah, I love that. And then if you could snap your fingers and change one thing to accelerate mass timber and prefab, what's something you'd change in Canada?
I would modernize the lumber and timber industry and forest industry from today to tomorrow.
Okay.
That's a massive undertaking. There's a lot we have to do. We have to invest. We have to rebuild a lot of companies, a lot of sawmills. We have to support the smaller firms and the smaller ownerships of forests, bring them up to speed, modernize them, build a lot of CLT plants, and then sort of catch up with the Europeans that have done this already for a few decades.
Perfect. I love that. This has been fantastic. Odie, thanks so much for spending some time and giving us a peek into this industry. It's been very eye-opening.
Really appreciate it. Thank you, Justin.
Thanks for joining us. If you enjoyed today's episode, leave a rating and a review on Spotify or Apple Podcasts. It would mean a lot and helps grow the show. To stay in the loop on Canadian climate tech news, recent fundraising, job postings, events, and more, subscribe to the Climate Tech Canada newsletter on our website. Thanks for listening. We'll see you next time.